This is our video for Unit 3, Day 4. So yesterday we talked a little bit about quadratic equations, talked about how to recognize them and to put them into standard form. Today we're going to actually be the first day where we go through and start solving these. So one of the easiest ways and quickest ways we can solve quadratic equations is to solve by factoring. What that means, we start with the standard form equation and we rewrite it as two easier linear equations, as two linear factors. In order to solve. So we take one hard equation and we split it into two easy equations. Remember that when we solve quadratic equation, we always get two answers. Right, and that's where these two answers come from. We take the one equation, split it into two easy equations. So the idea behind factoring, the way it works, is something called the zero product property. Or ZPP. So what the zero product property says is that if we have two quantities, two numbers that multiply to zero, one of them has to be zero. Right? You can look at your calculator sheet. You can see the only way we can multiply something and get zero is if one number or the other number is zero. So we can multiply two quantities. If they multiply to zero, if the product is zero, so zero product, then one of the numbers has to be zero. Alright, so in symbols, we write that with math symbols. Let's write if A times B is zero, then either A equals zero or B equals zero. There's no other way I can multiply A times B and get zero unless one or the other one is zero. So that's the basic idea behind it. Since we're always starting in standard form, that means we're always starting with something equal to zero. And that's why this factoring method works so well, the zero product property. So what I'm going to go through is how we actually go through and solve a quadratic equation by factoring. So the method we're going to learn is called factoring by grouping. So there are other ways you may have learned in other classes. Slip and slide or slide and divide is another method. In this class, we're going to do factoring by grouping. So the step zero, the main thing we always have to remember is to always start with our equation in standard form. Sometimes it's already in standard form for us. Sometimes we have to do a little bit of work. This one is already in standard form. Alright, so the way we know it's in standard form is that we can identify A, B, and C. In this case, A is what's in front of our quadratic term, coefficient for quadratic term. It's going to be 1, so there's no number there. B is coefficient for our linear term, so that'll be 7, and C is our constant term, 12. It's very important to watch signs, positive and negative also. If something is negative, we have to include that with A, B, and C. So we're going to do step 1 is we're going to look for factors of A times C. And so in this example, A times C, that would be 1 times 12, which is 12. So we're going to list all our factors of 12. And we're going to find the ones that add to B. In this case, B is 7. So what we start doing is we're just going to make a list of all the factors of 12. So now I can do 1 times 12, 2 times 6, 3 times 4. Now Now we're going to do with those numbers is see what each factor pair adds up to. So 1 plus 12 is 13. That doesn't work. 2 plus 6 is 8. That's closer, but it still doesn't work. 3 plus 4 is 7. So this is our factor pair. Alright, it multiplies to 12 and it adds 7. So once we find that factor pair, what we do is we split the middle term. So I'm going to do is I'm going to take this 3 and this 4. I'm going to rewrite 7 using the 3 and the 4. So I'm going to rewrite my equation as x squared plus 3x plus 4x plus 12 equals 0. So we use the 3 and 4 to split up that 7. That's the purpose of it. Now this is where the grouping comes in. It's called factoring by grouping. So what we're going to do is group the first two and the last two terms together. In this case, that's x squared plus 3x. We also have 4x plus 12. So once we group them, what we do is we're going to remove the common factors. So if we look at the first two terms, I have x squared and 3x. So if we look at the coefficients, 1 and 3 don't have any common factors besides 1. But x squared and x, I can remove an x. So I can rewrite it by taking out the common factor. Now look at my second two terms. I have 4x and 12. 4 and 12 both have a common factor of 4. If I remove that 4, what I'm left with is x plus 3. So notice what we get is we have the same binomial term twice, x plus 3. That's one of our factors. The other comes from the two common factors we removed. So if you look at the steps in reverse, what you're seeing is that's the FOIL process in reverse. We're doing is undoing the FOIL process, getting back to our two binomials. So we've done a lot of work so far, but we're actually still not done. Fifth step is one of the most important steps, one of the most frequently forgotten steps. We still haven't solved the equation. So we said each of these factors equal to 0 and solve. Alright, so this is a lot of good work here, but we haven't actually solved the equation yet. So to solve the equation, we have to set each factor equal to 0. And this is where that zero product property comes in. If I have x plus 4 times x plus 3 and equals 0, that tells me either x plus 4 or x plus 3 has to equal 0. So if I solve these, I get two solutions, negative 3 and negative 4. So it's a lot of steps. What we'll go through is the more we do it, the easier it will get. And once we go with this, we'll go through a couple shortcuts as well. So we'll do one more example, and then we're going to start going through some shortcuts. So we'll do number 2 as our example. So first thing we always have to do is put it into standard form. That one's not standard form because it's not set equal to 0. If we add 10 to both sides, now it is set equal to 0. Remember, we don't add the 7x and the 10 because they're not like terms, so we're going to write them all separately. X squared plus 7x plus 10. So it's in standard form. I can pull out my A, B, and C numbers. So remember, I'm looking for its factors of A times C. In this case, that's 1 times 10, or 10. And we'll find those factors that add up to B, which is 7. So if I list all my factors of 10, I have 1 times 10, 2 times 5, and that's going to be it. Add those up. 11. That one doesn't work. So 2 and 5 are going to be the ones that work. So once you get good with this, you won't have to write them all down. You'll be able to recognize them. But for right now, you write them down just for practice. Make sure you're using the right set. So now we take this 2 and 5. What we do is we split up this middle term. So I rewrite this as x squared plus 2x plus 5x plus 10. So I've broken that middle term up now. And the reason I do that is that I can have 4 terms. I can group every 2 terms together. Alright, so group x squared and 2x, pulls out a common factor. Again, this one doesn't have any common factor between the coefficients, but we can pull out a factor of x. Same idea with the second one. We can pull out a common factor of 5, and again, we see that repeated term again, x plus 2. It tells me that this is one of my factors, the repeated term. The other one comes from the common factor if you removed, x plus 5. Alright, so we factored it, but we still haven't solved the equation. We have to set each factor equal to 0 and solve from there. So there's 2 more example problems, so try those on your own. Make sure you're comfortable with this, and we'll start going through some shortcuts once we get comfortable with the main idea. So the one thing we have to be careful of while we're doing these problems is the types of factors we get. So we're going to get different types of factors depending on the sign, which means positive or negative, of our different numbers. So in AC, A times C, if that's positive, right, we're multiplying 2 numbers, getting a positive. That means we're either going to have 2 positive factors, since positive times positive makes positive, or we could also have 2 negative factors, since negative times negative is also positive. And that's going to depend on the sign of B, right? Since we're adding to get B, if B is negative, that means 2 negative factors. B is positive, 2 positive factors. When AC is negative, we multiply and get a negative number. Then we're going to have one of each. We'll have 1 positive factor and 1 negative. That's one thing we can do in terms of identifying the type of factors we'll have. It's just look at the different signs for different signs for AC and also for B. So we see, first example, we're not going to solve it. We're just going to go through the different types. We see that B is negative and C is also negative. Alright, so if AC is negative, that means I have to multiply 1 positive and 1 negative factor. So if I'm listing my factors for AC, it's 1 times negative 56, which is negative 56. Alright, we think about all numbers that multiply to 56. I could do 1 times 56, but I could do negative 1 times 56, or I could also do 1 times negative 56. Do negative 2 times 28, or 2 times negative 28. Right, I could keep going until I got down to the one that works here. So I would have negative 7 times 8, or negative 8 times 7. In this case, since b is also negative, the larger number needs to be negative. So in this case, we go with negative 8 times 7. But right away, just from looking at this, when we see that c is negative, that tells us we have one positive, one negative factor. So now look for that when we're going through the problem. Same thing here. What I have is b is negative, ac is positive. Alright, so that tells me I'm going to have two negative factors. Alright, since a negative times a negative makes a positive, and negative plus negative makes a negative. Alright, so down below there's a bunch of different problems for you to practice. There's 9 different problems. So you can get some practice factoring, and make sure you pay attention to the types of factors you're going to have, positive and negative. Those can help you identify your factors a little more quickly when you get good with looking at those signs. Now to make this a little easier, what we're going to do is go through some shortcuts. So there's 2 shortcuts we're going to go over today, and there will be a couple more we add in as we go. First shortcut is when a equals 1. So you write a quadratic equation in standard form. A is called the leading coefficient. Since it's the first coefficient, it's a quadratic coefficient, a quadratic equation. So whenever our leading coefficient is 1, we can shortcut our factoring process a little bit. And here's the way we shortcut it. First, we look only for factors of c. Right, instead of factors of AC, we just look for factors of c that add to b. So in this case, we'd look for factors of 7, and there's only one option here, 1 times 7, that add up to 8. Without having to do the AC process, we're just looking at C now, and we're looking at B. Now, once we have those factor pairs, we can jump straight into splitting it up into our 2 factors. We don't have to go through the factoring by grouping process. That's a pattern, if you noticed from all the problems you did on the practice sheet, right? This pattern you should have seen there is once you get those factor pairs, those end up being your factors for all those problems where we have 1 as the leading coefficient. And from there, we solve the same way. Set them equal to 0, and solve. Same idea here on the second one. We have C is negative 18. B is a negative 3. So we look for 2 numbers that multiply negative 18 and add up to 3. So you can write out your list, and what you'd eventually find is that we can use a negative 6 times a positive 3. So we go ahead and split that up. X minus 6, x plus 3, and then solve. Set each factor equal to 0, and get our 2 answers of negative 3 and positive 6. Alright, so that's a big shortcut. We basically cut all the middle steps out of factoring by grouping when our leading coefficient's 1. So that's a big shortcut. Here's one other type of shortcut is when b equals 0, we have something called a difference of squares. Alright, so anytime we have a quadratic equation that has two terms separated by subtraction, both terms are perfect squares, we call this a difference of squares. We can factor this really quickly. So we have something that looks like a squared minus b squared equals 0. That's what it'll look like. We factor it as a plus b and a minus b. So we use the square roots. One is addition, one is subtraction. So I'll show you how this works. So the first one I have x squared minus 64. Alright, so we're using the square root. So square root of x squared would just be x. Square root of 64 would be 8. So I have x and 8, x and 8. One is addition, one is subtraction. And we solve, we'll see we get a positive and negative 8 as our two roots. Same idea with the second one. Alright, we know square root x squared is going to be x. Square root 9 is 3. So factors using x and 3. One is plus, one is minus, and our two roots come out to be positive and negative 3. Same idea here, if we put it in standard form. You have the same thing with a perfect square. Square root of 49 is 7. We can factor it quickly. X plus 7, x minus 7, and our two roots of positive and negative 7. So that's it for this video. Again, the shortcuts we'll be using most of the time, but I want to point out they're not going to work for every quadratic equation. Alright, they're only going to work for the two types we talked about on this page. So where a is 1 and where we have a difference of squares. If it can't factor, doesn't fit one of these shortcuts, we're going to have to use the long way, the factoring by grouping.